In the last lecture module, we looked at the properties that cognitive scientists associate as central to or definitive of the strategy that they call System 1. Now we want to turn our attention to System 2 and look at the features that distinguish System 2 from System 1 as a general information processing strategy. So while System 1 exhibits automaticity, and we engage these processes automatically and with little effort at all, System 2 has a quite different profile. It's not automatic. It's not easy for us to engage these processes oftentimes unless we're contextually cued, unless the situation gives us an indication that we need to solve a problem this way, that this is the kind of problem that we're faced with, then oftentimes it'll be difficult for us to just independently recognize that this is the kind of problem that we should use this strategy to address. And so oftentimes cognitive scientists will say things like System 2 strategies require cognitive decoupling. And what does that mean? Well, what cognitive decoupling means essentially is that we have to step back from the immediacy of the problem and employ our working memory to generate a representation of the problem that is independent of the features of the problem that we're directly perceiving. So when we quantify something and then solve a problem using mathematics, that is a case of cognitive decoupling. System 2 inference and decision-making strategies are non-autonomous. They rely quite heavily on our working memory. And so what we discover is that because our working memory has this very limited capacity, our System 2 inference and decision-making processes are also very limited in the information that they can employ and the complexity of the information that they can process. They also tend to operate serially. So to deal with the information bottleneck in working memory, what we tend to do is solve one aspect of a problem, then another aspect of a problem, and then another aspect of the problem. Because we have such limited representational capacity in working memory, we tend to break that problem down into a series of steps that we execute. We need to consciously be aware of and attend to our System 2 strategies. So when we employ a decision or inference making process, we have to consciously be aware that we're doing it. We have to execute conscious oversight. We decide that this is an appropriate strategy for solving this problem. And then in executing that strategy, we consciously monitor the process and make sure that it's executed in the way it's supposed to be executed. Now, the benefit of that is that we have a reasonably good conscious insight into how we solve the problem and the sorts of information that was important in our problem solution. Another feature of System 2 inference strategies is that they oftentimes are highly decontextualized. So they're oftentimes strategies that were developed by incredibly intelligent people who are thinking about the underlying structural features of problems and seeing commonalities. So for instance, when we learn categorical logic later in the term, categorical logic is a means of representing the underlying structural relationships in a particular kind of deductive inference. And by doing this, we're capable of evaluating those inferences and not being misled by superficial content and context features of them. So oftentimes, when we solve problems, for instance, by quantifying things and then using mathematics, or when we solve problems by looking at underlying structural relationships as opposed to superficial features of the problem or the objects that we're dealing with, that is characteristic oftentimes of System 2 inference and decision-making processes. they are often learned processes, though they're not always learned processes. This is one of the benefits of our social cognition, of our being part of these large information ecosystems. When a good problem solution, when a bug fix to a system one inference strategy emerges, for example, then that gets shared and it gets taught and it gets propagated. And so we then have this pickup of that kind of strategy and its utilization in system two. So what about the interaction between system one and system two in regular problem solving contexts? Well, in a typical situation, when we run across a particular inference or decision-making problem, system one is going to automatically kick in, operating autonomously, that is, relatively independent of our working memory and hence relatively outside of our conscious awareness. It's going to operate using highly associative and highly contextualized inference strategies and decision-making strategies, and it's going to generate a solution pretty quickly. System one then is going to be like a train. It's going to be barreling down the track towards its destination, relatively oblivious to details that might be picked up by our conscious awareness of what's going on or the dimensions of the problem that get into our conscious awareness. Now, system two, in contrast, is going to be heavily dependent upon our working memory, on our conscious awareness and assessment of the problem. And for that reason, it's going to be difficult for us to engage because our working memory is constantly being absorbed just by all the information that we're being bombarded with all the time. And in order for us to engage that system two process, we have to identify that something might have gone wrong on system one. So system two is sort of like an engineer sitting on that train, except he's sort of an engineer who isn't particularly attentive or alert, doesn't notice things as often or as quickly as we'd like. If something doesn't go dramatically wrong, our system two engineer may not notice it at all. So if our system two engineer gets a cue from the context of the problem or has some working memory capacity that allows system two to identify that, hey, she's got a problem up ahead here, then system two can engage and operate. Again, its operation is going to be slower than system one. It's going to be serial because of that working memory bottleneck. There's just a little information that gets processed at a time, and so it's much more of a stepwise process. But it can oftentimes bring to bear a bunch of information that's highly decontextualized, information about the underlying structural relationships of a problem or a decision that our system one barreling down that track is really inattentive to. Now, in order for our system two strategy to win the day and to generate the solution or the decision, it has to inhibit the processes and the answers that are given by system one. And so in that What is Critical Thinking lecture that we started off the term with, I emphasized this idea that critical thinking education isn't going to result in this dramatic change in the dynamics of how you make inferences and decisions. And this is the reason why. It's difficult for us to override these automatic and autonomous inference and decision-making processes using this other strategy, because we have to, first of all, know that the strategy is available to us. We have to recognize that it's relevant. We have to recognize that we can solve that problem in a better way, or that the way that we might normally solve that problem isn't very good. And so it can be difficult for us to engage that system two, and it will take a little time for us to engage it, whereas that system one is just barreling down the track.